In this video, I will consider one example on design of FIR filter using rectangular window. Design an FIR filter with the following desired frequency response. Here frequency response of the desired filter is given, that is HD of omega. Use rectangular window function. Draw the direct form structure for the designed filter. The normalized magnitude frequency response of desired high pass filter is shown below. So this is the magnitude frequency response of the desired high pass filter. So here HD of omega, that is magnitude, as we seen here, HD of omega value is 0 if omega value is less than 5 by 6. Let this be 0. This is omega axis. Let this be plus pi by 6 and this is pi. Similarly, this is minus pi by 6 and this is pi. So here the value of HD of omega is 0 if omega is less than or equal to pi by 6. Here we can see that HD of omega is 0 from 0 to pi by 6, and here on negative side also it is 0 from 0 to minus pi by 6, and its value is e power minus j4 omega if omega is greater than pi by 6. That is pi by 6 to pi, its value is e power minus j4 omega. That is the magnitude of this is e power minus j4 omega. So here we can see that usually it is represented as e power j tau omega. So comparing this with this equation, I can say tau is equal to 4. Also we know that tau is nothing but m minus 1 by 2. Therefore m is equal to 2 tau plus 1, that is 2 into 4 plus 1, that is 9. So size of the window is m is equal to 9. So the first step is, now we supposed to calculate desired unit impulse response HD of n. Compute desired impulse response HD of n, that is HD of n is equal to 1 over 2 pi integration minus pi to pi HD of omega e power j omega n d omega. So simplifying this, HD of n is equal to 1 over 2 pi. Here we can see that it is varying from minus pi to minus pi by 6. So one integration limit is minus pi to minus pi by 6. HD of omega value is given, that is e power minus j4 omega, e power minus j4 omega into e power j omega n into d omega, plus similarly another limit is pi by 6 to pi, that is plus pi by 6 to plus pi e power minus j4 omega into e power j omega n into d omega. That is HD of n is equal to 1 over 2 pi so I can write it as minus pi to minus pi by 6 e power j omega n minus 4 d omega plus pi by 6 to pi e power j omega n minus 4 d omega. So now we'll take the integration of these two terms. Simplifying this, HD of n is equal to 1 over 2 pi the integration of e power j omega n minus 4, it gives as e power j omega n minus 4 divided by j of n minus 4. Let me apply the limit, that is minus pi to minus pi by 6, minus pi to minus pi by 6, plus similarly integration of this is same, that is e power j omega of n minus 4 divided by j of n minus 4. Here the integration limit is pi by 6 to pi, pi by 6 to pi. Now let me simplify further, that is hd of n is 1 over 2 pi. So here now omega is the variable, so I will replace omega by minus pi by 6, that is e power minus j pi by 6 n minus 4 divided by minus, here now substitute pi value, that is e power minus j pi, e power minus j pi of n minus 4 whole divided by j of n minus 4, plus similarly apply the limit here, omega is the variable, that is e power j pi of n minus 4 minus e power j pi by 6 of n minus 4 divided by j of n minus 4. Then I can simplify this as hd of n is equal to, here we can see that j of n minus 4 is the common in both the sides, so this will be the LCM. I will take n minus 4 out of the bracket and I will represent this 2 inside, so that I can represent it as 1 upon pi. I'll take n minus 4 outside the bracket, n minus 4 in bracket. On numerator we have e power minus j pi by 6 of n minus 4 minus e power minus j pi of n minus 4 plus e power j pi of n minus 4 minus e power j pi by 6 of n minus 4 whole divided by, I can write, I'll take this 2 inside and j is common, that is 2j. Simplify this as hd of n is equal to 1 over pi of n minus 4 e power minus j pi by 6 of n minus 4. Now I will take this term this side, I will take this term, that is minus e power j pi by 6 of n minus 4 divided by 2j. Now I will write this term, that is e power j pi of n minus 4. Then I will write this term, that is minus e power j pi of n minus 4, that divided by 2j. So further in next step I will represent this term first and this term next, that is I can write this a hd of n is equal to 1 over pi of n minus 4 e power j pi of n minus 4 minus e power minus j pi of n minus 4 divided by 2j minus, now I will write this term first and this term next, that is I can write e power j pi by 6 of n minus 4 plus e power minus j pi by 6 of n minus 4 divided by 2j. Now we know that e power j theta minus e power minus j theta divided by 2j leads to sine theta. So I brought this into the standard format of this. Therefore, further I can simplify this as hd of n is equal to 1 over pi of n minus 4. So here e power j theta is nothing but pi of n minus 4. So I can write sine of theta is pi of n minus 4 minus, it is also standard form, that is sine theta. Here theta value is pi by 6 of n minus 4, that is sine pi by 6 of n minus 4. So this is the standard equation. I will call it as equation 1, and here n varies from n is equal to 0 to m minus 1, that is n is equal to 0 to 8 because m value is 9. So now for n equal to 4, equation 1 leads to 0 by 0 form, so which is indeterminate. So now we supposed to solve it using L'Hospital rule, that is applying L'Hospital rule. L'Hospital rule is given by limit alpha tends to 0, sine of a alpha divided by alpha, it gives a. So therefore apply L'Hospital rule to equation 1. I can write hd of n is equal to 1 upon pi limit n tends to 4 sine pi of n minus 4 divided by n minus 4 minus, here I have another term, that is limit n tends to 4 sine pi by 6 of n minus 4 divided by n minus 4. So here now we can compare this expression with this. Here sine a alpha by alpha is equal to a. So in this case alpha is nothing but n minus 4, and here also we have n minus 4. So alpha is n minus 4 and a is pi. Similarly in this equation a is nothing but pi by 6 and alpha is nothing but n minus 4. So by applying L'Hospital rule, here it leads to pi and this leads to pi by 6. hd of n is equal to 1 over pi minus pi by 6. So simplifying this, I'll get hd of n is equal to pi into pi, that is 1 minus 1 by 6, which is equal to 5 by 6. So therefore hd of n is equal to pi by 6 for n is equal to 4. Now we'll write the next step, that is step 2 is we supposed to find impulse response, that is h of n is equal to hd of n into wr of n. Here wr of n is rectangular window. Let me define the rectangular window. Here wr of n is rectangular window which is defined as wr of n value is equal to 1 for n equal to 0 to m minus 1 and its value is 0 otherwise. So therefore impulse response h of n can be written as hd of n, which is already we have calculated, that is Therefore, h of n is equal to hd of n is nothing but sine pi of n minus 4 minus sine pi by 6 of n minus 4 whole divided by pi of n minus 4. This is from equation 1. Into we have to multiply with rectangular window, and rectangular window value is 1. So now we are supposed to calculate h of n for different values of n from 0 to 9. That is, for n equal to 0, 1, 2, 3. So 4 is already calculated, 5, 6, 7 and 8. So now consider this table. Here n is the variable, hd of n is this term. So here this is hd of n and wr of n, this is wr of n. The multiplication of these two leads to h of n. Let me find h of n for different values of n. So for n is equal to 0, hd of n will be minus 0.0689. wr of n value is always 1. Multiplying these two leads to minus 0.0689. Similarly, for n equal to 1, its value hd of n is minus 0.1061. That is, substitute n equal to 1 in this equation, will get hd of n, and its value is 1. Multiplying these two leads to minus 0.1061. For n equal to 2, substitute n equal to 2 in hd of n in this equation, will get minus 0.1378. This is 1 always, that is minus 0.1378. For n equal to 3, it will be minus 0.159. This is 1, that is minus 0.159. For n equal to 4, already we have calculated this. The hd of n is 0.833, that is 5 by 6, and its value is 1. Multiplying these two gives 0.833. Similarly, for n equal to 5, it is same as for n equal to 3, that is minus 0.159 minus 0. This is 159. Similarly, for n equal to 6 is same as for n equal to 2, that is minus 0.1378 minus 0.1378. N equal to 7 is same as n equal to 1, that is minus 0.1061 minus 0.1061. For n equal to 8, it is same as n equal to 0, that is minus 0.0689 minus 0.0689. So this is the impulse response values h of n. Here we can observe that value of h of 0 and h of 8 are same. Similarly, h of 1 and h of 7 values are same because of symmetric nature. 2 and 6 are same. Similarly, 3 and 5 values are same because FIR filter possesses symmetric rule for m equal to 9. So now, before drawing the direct form structure, let me write the transfer function h of z. That is, h of z is equal to summation n equal to 0 to m minus 1 h of n z power minus n. Simplifying this, h of z is equal to, I'll substitute different values of n. This can also be written as n is equal to 0 to 8 as m equal to 9 h of n z power minus n. So simplifying this or expanding this summation, I can write. So substituting n equal to 0, it will be h of 0 plus h of 1 z power minus 1 plus h of 2 z power minus 2 plus h of 3 z power minus 3 plus h of 4 z power minus 4 plus h of 5 z power minus 5 plus h of 6 z power minus 6 plus h of 7 z power minus 7 plus h of 8 z power minus 8. Now substituting the values of h of z, that is h of z is equal. So h of 0 value is minus 0.0689. H of 1 value is minus 0.1061 z power minus 1. H of 2 value is minus 0.1378. H of 3 is minus z power minus 2. H of 3 is minus 0.159 z power minus 3. H of 4 is 0.8333 z power minus 4 plus h of 5 is minus 0.159 z power minus 5. H of 6 is minus 0.1378 z power minus 6. 7 is 0.1061 z power minus 7 and 8 is minus 0.0689 z power minus 8. We know that h of z can also be represented as y of z divided by x of z. So therefore we can write y of z is equal to h of z into x of z. So now by taking inverse z transform of this, I can write y of n is equal to, here we have minus 0.0689 x of n minus 0.1061. We have z inverse, that is x of n minus 1 minus 0.1378 x of n minus 2 minus 0.159 z x of n minus 3 plus 0.833 x of n minus 4 minus 0.159 x of n minus 5 minus 0.1378 x of n minus 6 minus 0.1061 x of n minus 7 minus 0.0689 x of n minus 8. So this is the difference equation. Here we can see that x of n coefficients and x of 8 coefficients are same. Similarly, x of 1 coefficient and x of 7 coefficients are same. X of n minus 2 coefficients and x of n minus 6 coefficients are same. Similarly, x of n minus 3 coefficients and x of n minus 5 coefficients are same. So by seeing this y of n, we can easily draw the direct form structure. Our equation y of n, x of n has value from 0 to 8. So we need 8 delay elements. So let this be x of n. This is x of n minus 1, x of n minus 2, minus 6, x of n minus 7, and here the output is x of n minus 8. 0 and x of 8 values are same. So I can take one adder here. Input to this is x of n minus 8. The coefficient of x of n minus 8 is minus 0.689 and coefficient of x of n is minus 0.689. Both are same. So here This is connected to here. This is minus 0.0689. Here also it is minus 0.0689. Similarly, x of n minus 1 and x of n minus 7 values are same. So here I can add those two. You can connect it like this. Minus 0.1061. Here also it is minus 0.1061. Similarly, 2 and 6, x of 2 and x of n minus 2 and x of n minus 6 coefficients are same. This is x of n minus 6, and here we have x of n minus 2. That is minus 0.1378. Here also it is minus 0.1378. Similarly, x of n minus 3 and n minus 5 coefficients are same. So this is minus 0.159. This is also minus 0.159. So therefore now I can add all these inputs. Another input is x of n minus 4. This is connected here, and this is connected here. So this is final y of n. So this is the direct form structure for the given FIR filter. Thank you for watching.